fill the blanks. So the blanks are all over here. Okay, in all of these rows. What is given is if the original wire's length is L, area of cross section is A, resistance is R, and resistivity is rho. So we are looking at what we are doing over here. We are doubling on it, folding to 1/3 the original length, folding to 1/5, so on and so forth. So basically the question talks about this. I have a wire, right? So this wire, what we are doing here is we are increasing the length, if not decreasing the length. So we know in turn it will change the area of cross section. So the question is, to what extent will the length, area, and the resistance and the resistivity will change? That's the whole question. So when we double something on it, doubled on it, it means that the length is decreased by twice. Okay, so basically doubled on it means this length is decreased by 2 times, and the area of cross section will double. Okay, so the area of cross section will double. That's how the area of cross section changes. Resistivity will what? Resistivity will not change. It will be same as whatever this is. Okay, so the next question is, will the resistance increase or decrease? What do you think? So we have a wire, decreasing the length, and the area of cross section is increasing. So will I be spending less energy or more energy in transferring electrons from one end to another end? Less energy. And by how much less? By 4 times, 2 square. Whatever this value is, square that by 4 times. If I fold the wire to 1/3 the original length, so this wire, if I fold it to 1/3, so it will be 1/3 this entire length. If this is 6 centimeter, this entire length is 2 centimeter. Okay, so 1/3 the original length. The area of cross section will increase by 3 times, while the resistivity will remain the same, and the resistance, of course, will reduce to what? To 9 times, 3 square times. So fifth one, 1/5 is not a big surprise over here. It is just L by 5, 5A, right? Area of cross section will increase by 5 times. Resistivity will not change. Resistance will decrease by square of 5. Now, new set of case. We are drawing the wire to a new length, double the length. That is, we're increasing the length by 2 times. Okay, so this is 2L. Area of cross section will reduce by half, is it not? So if I increase the length, the area of cross section will reduce. Any doubt, just take a rubber band and just have a look. The resistivity will decrease or increase. Nothing will happen. It will remain the same. Make sense? Now, the question is, will the resistance increase or decrease? Think about it. We have a wire. Now, same wire has been pulled twice the length. Means the electron has to go twice the length, and in a space that is smaller than what originally it was. So obviously the resistance, it will take more energy, means the resistance will increase. To what times? To 4 times. 2 square into R. When you triple the length, what will happen? This will be 3L. Area of cross section will reduce by 3 times. Resistivity will not change. Resistance will increase. Right? So the resistance will increase by 3 square times. If we draw the length to 5 times the length, so this will be 5L. Area of cross section is A by 5. Resistivity is rho. The resistance will increase by amount 5 square times, that is 25 times. Okay, it will be very thin, and area of cross section obviously is very small, and the length is 5 times more, right? So overall resistance will increase by 25 times. Okay, so this are set of possible MCQ questions or a 1 marker question, right? But I feel this is more of an MCQ question. So any such pattern, I hope you guys understood. If we fold on itself, things will happen in this way. So understand to what length it is reducing or increasing. Then you will be able to answer this. Without understanding this, please don't answer, because the language can be in many ways. I've just quoted what I feel is in your syllabus as of now. But of course, any point of time, teachers can change the language. It's not a big thing. It's just the language. If you understand that, doing the math is not that difficult. Again, it's just that I have seen many kids understand the concept, but the language is something which is not easy. So just try to be careful. Read once or twice of what they're asking you to do with the length, and the answer will just pop out. Okay, so you can pause and have a look.